So, talking about Microsoft and the Internet of Things in this last half hour of today. My name is Sascha Corti. I work for Microsoft Switzerland as a technical evangelist together with Ronnie in the team, and I've been focusing on the Windows platform, writing code application for Windows Phone, and we are now really also focusing much more on the cloud, and for me this is looking at the Internet of Things. If you like what you see today, if you think this is quite interesting what people have shown me today, I might be interested in future events Microsoft does. Our team, actually I redact it, we do a newsletter. If you are interested, it's just top stories every 2 weeks and a calendar of upcoming events. I try to keep it absolutely spam-free. Sign up for that newsletter. You can always cancel it. I promise it will work. You can take me personally responsible if it doesn't. And the other thing is we have an opt-in card. This is a little paper card you have gotten here today, or you can get here today. And if you fill that and return it to us, you will get select messages from us inviting you to events, to things we do that we think are of interest to you. So these are 2 ways I highly encourage you to take a chance in keeping in contact with us in future when we do things that we think are interesting for you. So now to the Internet of Things. I did this presentation starting roughly this year, which for IT is a very long time ago. And there was this information I got from Redmond, and it said, well, in 2008, we have passed the point where there were equally amount of internet-connected devices on the planet as there were people. By today, it's many times more connected devices than we have people on the planet, and by 2020, we will have 50 billion always or connected devices that can talk to servers on the internet. And I thought, wow, that's quite amazing. And since I did this presentation in probably April, things have changed. The media has evolved, and come on, slide. My 50 billion have gone up to 75 billion. You see the posts, the online articles stating these numbers by 2020. And in the meantime, we're up to 212 billion devices connected to the internet and delivering data to some servers, some kind of servers, by 2020. So the trend, it feels a bit like a hype. Now, everybody's talking about it. Everybody is hyping the topic. What is it about? Is it something real? Is it just a hype? Do I have to care about this Internet of Things? I say it's something very real. It's basically taking data that sensors and objects and various pieces of hardware deliver, collecting that data and use it to gain insight, to monitor, to analyze, and to control and to really gain information out of all that data and to help control these connected systems, or even large systems like entire factories or companies with the insights gained. So the Internet of Things is made up of things, of course, the devices. Classically, these are said to be embedded devices, some sensor somewhere that talks over the network. It has some kind of software that runs, it collects data, it stores the data, and then of course it transmits the data out into the network to an enterprise backend, for example, which collects the data, analyzes, and has analytics and BI run on top of it. But by collecting lots of data over a long time, you can really gain insights that are far beyond the single piece of data you collected. And if you go even further, you can use this network connection to the device to go back from the system into the embedded device to update it, to control it, to manage it, and to really create a self-driving, organized system. And it doesn't have to be a new embedded device that you buy or invent. Many of the devices are there, many of the systems are in place, just a lot of the data generated is not used a lot of the time. And if you start using the data that is already there in existing systems, be it hardware, be it software, be it log files from some server, you can start using algorithms that analyze that data and that get valuable insights. And the enterprise backend, of course, now transforms a lot to the cloud. And this is an area where I think cloud computing is very significant. I have a section on that a little later, but you don't have to do that all internally on your own servers. I think the cloud is very relevant in this Internet of Things world. Now, if I say that there's 212 billion devices generating data that needs to be collected, of course, that's a lot and a lot of data. And when we had the times of ERP, CRM, we were in the petabytes of data collected. Now, in the Web 2.0, where we are currently, we are in the exabytes of data, and of course, you can imagine the Internet of Things, the amount of data generated rises even more. Luckily, at the same time as the data generated or accumulated rises drastically, so inversely does the price of storing the data. Now, storing data, the gigabyte of data, the price has from $190,000 for storing a gigabyte of data in 1980, it has come to virtually zero, being virtually free. OneDrive now offers unlimited storage to users of Office 365, and in general for cloud computing users, storing data luckily is something now very, very cheap. The benefits of using this Internet of Things and harnessing this data is, I think we saw a lot of it in the previous presentation, is you have a live feed of data and you can start to search for information, for trends, and start to optimize your patterns, your behaviors, your work based on the insights you get from collecting all the data. You can even work with a prediction engine and say, aha, the history has taught us that if it gets hot outside, this product sells a lot better. The history has taught us that if we're driving our trucks on Tuesdays, this and this part of the city are congested. We have much more time we need to get to the customer. We take different routes during these times. These can be everything from managing the machines inside a company, managing the computers or the data flow inside the company, to managing the cars on the street. Because all of them now collect data. Most of them are able to send data back to the internet, and it's a matter of harnessing that data and having the software being able to predict optimizations and future outcomes based on all the data it collected and all the insights it gained from looking at that data. And of course also social plays in here. If you start to collect social media information, as we saw in the previous demonstration, you can have the system analyze social media and say, what is the sentiment of my product? I could have left that knowing that we had this perfect demo in the previous session. So a couple of more practical examples. This was a bit theoretical. So before IoT, you would have delivery schedules based on distance and maybe historical traffic patterns. Today, you can do that in real time. You have real-time routes, real-time alerts that the driver knows when to exactly go where and which vehicle is the most efficient to go to a certain place. Or you had equipment maintenance performed in a regular schedule interval because you wouldn't know when they break. Now, if you start collecting information from the equipment, you can perform the maintenance when a failure is predicted. Microsoft has done a project, we call it 88 acres, and we have taken a lot of sensor data we have in the Redmond campus, existing sensors. So, for example, in an office building, we have inside temperature, we have outside temperature, and we have the energy consumption of the air conditioning. Now, if you look at that for a couple of weeks, you know that if it's very hot outside and you need it's America, so it needs to be very cold inside for people to work, and for me to instantly get a cold when I travel there, you need this and this amount of energy. Now, if suddenly you require a lot more energy to reach the same temperature, or with the same energy you don't get the same temperatures anymore that are expected, you can start predicting a maintenance case, a machine failure, probably the air conditioning, somebody left the window open, that's a bummer, or the machine fails. So this is a very simple sample that we do in Redmond now with a lot of data that it has always been there, but it has never been used in this way. Another one is you sell replacement parts and provide a repair service in classical world versus you have a maintenance subscription, and the tech proactively visits you when he finds out that your equipment will soon fail and need services. I have a car. My car is constantly internet connected and sends data back to the manufacturer. And when they see something out of the order, they call me and send a ranger to change something. I didn't even know there was no check engine light, but they send somebody to fix something proactively. Today, it's already there. Or service people that visit a vending machine because they do that every week and they find it totally full because nobody ever bought anything, or it has been empty for 3 days and people wanted to get some water and they couldn't. And now the vending machine can talk back and say, hey, I'm running low on Coke, please dispatch somebody to refill the Coke. Or even with advertising, you can, of course, create much more targeted scenarios where, based on the person looking at an advertising, the advertising changes to that person's needs. Of course, it's always, is that secure? Is that privacy? Do I want that? Everybody in the future will have the possibility to go dark if they don't want that, be completely anonymous and off the grid. Or if they really want this, they see it's useful, they can go active online and say, now I want targeted advertising, now I'm interested. And I've grazed a couple of areas, industry, transportation. There is a lot of areas that will benefit from the Internet of Things, from factories to cities to simple homes, home automation. If your home has more sensors and some intelligence, your home can tell you if something's wrong, or if you should come home and water the flowers or feed the cat. Healthcare, everywhere you look, data is generated and insights can be gathered from that data. And IDC has done a study. We presented that at the partner conference this fall, and they say this year, 2014, there is an estimated revenue of $1.93 trillion in this area of the Internet of Things, which by 2018 will go up to about $5 trillion. So not just for people creating the Internet of Things, but also for people who harness the Internet of Things to gain insights. There's a lot of benefits to be reaped. Now, the technology behind the Internet of Things is first, cloud. I said cloud computing will become very interesting. I already mentioned something about data storage being very cheap. What else makes the cloud, in my opinion, perfect for the Internet of Things is first that the cloud is very elastic. So if you need to grow, if you find out that you have much more data than you expected and you want to collect it, you need more instances to process it, you just drive up additional instances, and a lot of the management of the systems in the cloud is out of your hands, back at Microsoft, in the data center where the systems are being kept fit and on the newest OS or patch levels. Now, looking at Azure, I think the interesting part here is the elastic compute here. It spins up instances very fast if you need more computing power. Same with the storage. It scales on every aspect, storage, queues, everything, and it's really cost efficient. There is an Azure Service Bus that is made to get a lot of incoming message. A car vendor did a test with Internet of Things, and they had a lot of cars driving and sending data, and they ended up with having 10 million messages per second that they needed to process. And Service Bus is made for these scenarios, and it scales very well. Same for storage, grows as your needs grow. And notification, you can notify people, users, phones, but you can also send push notifications to devices, to Internet of Things components running on completely different platforms, Android, iOS, Windows. Very interesting way of talking back to a user or an Internet of Things component. And then there is Hadoop or HD Insights using Hadoop technology, and it's basically tackling the problem that you have huge number of data that you need to analyze, and by clustering the data, you also need to have a software that analyzes this data, which is aware of the data being clustered. And Hadoop does exactly that. It can cope with data being clustered and the processing of that data also being clustered across a huge number of systems without losing the big picture of the whole processing. And one interesting system that we are just introducing now is the Azure Intelligent Systems Service, which is basically the service that allows you to connect securely, securely connect your various devices running on various operating systems to automate alarms and response actions based on the data collected, to analyze it using graphical, visual, familiar tools, Excel, Power BI, as we saw in the previous presentation, and to then monitor and even update devices remotely, and doing that all in a secure way using encrypted data transmission. And I have a little case here showing this in action.
Carrying more than 1 billion passengers every year, the iconic London Underground is the world's first underground railway. I'm Stu Pears, Managing Director at Telent Technology. We wanted to help rail organisations like London Underground modernise the systems that monitor its critical assets. Everything from escalators and lifts and HVAC control systems to CCTV and communication networks. We teamed up with CGI and Microsoft. This collaboration includes taking advantage of the Microsoft Azure Intelligent Systems Service. Meaningful data from sensors and intelligent edge devices on everything from temperature, vibration and humidity to fault warnings and system alerts are available securely in the cloud. Many manual monitoring processes can now be streamlined. Disconnected systems can be securely integrated and automated. Most importantly, equipment degradation can be spotted in real time based on live data. And with new insights from data, London Underground can measure asset performance over time. When one system can connect thousands of devices and data streams across a rail network serving millions of people, that's the Internet of Things, and it's here right now. That's why we chose Microsoft.
Thank you very much. Azure. So, if on one side you have the cloud to collect the data, you may be interested in creating the sensors and devices that do the data collection and transmission. And we have various platforms for that, from Windows Embedded for industrial devices to Windows Phone or Windows Embedded Handheld for ruggedized phone-like devices, down to Windows Embedded Compact for very small devices like little network components, routers, with smart intelligence that can store data, measure, send data to the network, or the .NET Micro Framework or .NET running on a chip on these Netduino or Galileo boards for you to build something like that. And in this area, I have a partner here, Amiego. I'd like to invite Cyril Iselin on stage. They built a system built the sensors themselves and the cloud solution, and thank you very much.
Thank you very much, Sasha. Good afternoon, ladies and gentlemen. I'm proud to present you a real-life and existing scenario about the big theme, Internet of Things. My name's Cyril Iselin. I'm the CTO of Amiego Pty Ltd. I'm a software developer and mainly work with Microsoft technologies. We have spent the last 3 years designing and developing the new system called Amiego. Amiego is designed as a fast-to-implement productivity-boosting tool that allows you to manage and visualize any production environment. This can be a production machine or any other fixed or mobile workplace where activities happen. A service-based interface allows to connect any third-party system like an ERP system. The cloud-based service approach enables a fast and easy implementation with a minimum CapEx and is financed by itself as OpEx. Hardware devices or an OPC connection collect production activities and deliver them to the cloud. All 3 main types of smartphones are supported with a dedicated app. For an advanced production visualization, setup and administration, we have a web application, which runs on all modern browsers without any plugin. Let us show this.
Browser.
Okay. Danke.
You're welcome.
Let me log in to our demo environment. And here you can see the tile-inspired menu of Amiego. I'd like to demonstrate you our production environment. Here you see machine groups. This can be a department or any part of a factory. It shows you the consolidated status of each individual group. We see here the individual status of each machine. All visualized views are in real time. This is the Amiego's operator's view. Internet of Things in our demonstration case means a hardware device with a SIM card inside that is connected to Azure.
Okay, so let's show the hardware, I think. So I'm going to use my phone as a camera here. It's a bit. A lot about the Internet of Things is working with small devices and trying out stuff. So come on, yep, please. And now I'm starting the camera, and you will see.
We see here the device which is connected to Azure, and next to this we see a small custom-made device which will simulate a machine so that I don't have to put a machine here, so I can take a small device which will emulate this.
And we have the 3G antenna over here.
Yeah, exactly.
So this one talks to the network, has the SIM card inside.
Yes, right.
And this could be any machine you connect to.
This will generate some impulse like digital or analog.
Okay, and that's basically generating the data that you want to measure in the cloud.
Exactly.
And he sends it all to the cloud. Okay,
perfect.
So let's try this. If I can get this to close. And here is your system back.
Thank you very much. As you can see, our machine is not running. Now, I will send an impulse which informs our system that the machine is running. Now the state should be refreshed. Our device collects the data every 5 seconds and then we'll send it to the cloud. So I don't have a very good internet connection here or a small problem with our device. Usually you will see the status will be refreshed and you will see the actual state. Maybe it's because we are in a cinema.
They always tell you to turn their phones off. Now we know why. So maybe we'll let this refresh and look at it in a minute when it had time to. I mean, it's a huge machine. It needs some time to power up.
It looks like the machine is sleeping. So let's go to the visualization. Besides production statistics, Amiego can also visualize a timeline. This is an interactive view of production activities over a selected time period. Thank you very much for your attention.
Let's quickly go over to see if the machine has talked to us in the meantime. Can you just give it another shot? It worked before. It just took a while. See if our machine is working. Is it?
No, it's not.
So we will have automatically a repair technician coming in now. Hopefully. Thank you very much.
Thank you
Cyril.
very much.
So, in summary, I think the Internet of Things, even though it does look a bit like a hype when you read about it in the press today, is real. It's a real thing. It offers big opportunities for people who create these systems, but also for people who use them to analyze the data they most often already have and gain insights from that. As I said, a lot of the data is already there, just not being used. And I would say the cloud is very, very, very well suited for analyzing these lots and large amounts of data that can vary based on time or based on production volumes that you have. And Windows, I'd say, also is a great, great platform for creating your own Internet of Things devices, be it as a hardware prototype using a small board with .NET on a chip, up to a really embedded system like a pump or a machine or a medical control or a medical system that talks to the network and sends relevant data back to a server. Now you will get these slides after the event. You will get a thank you email. You get links to our slides. I have a couple of links in here. First to our Internet of Things page and also to our Microsoft Virtual Academy. It's a free online learning resource. You just open it in your browser, you click the courses you'd like, and these are videos showing in detail how these things are done. For example, there are 2 MVA courses I found that have to do with the Internet of Things. If you're interested in going into more technical detail, most of these videos are created by the teams in Redmond that create these technologies, so highly interesting. And as closing comments, I can only thank you very much for being here today, for listening to us, even after Satya left. And you got a feedback form. We'd be very, very happy if you fill that, if you give your feedback, so give it back to us so we can learn what we did good, what we can improve on. And I'd like to invite you to a standing lunch over at the Mascot. I think you will be guided perfectly once you leave the cinema. So you will see us there. I'll be there. Cyril will be there. So if you're interested in his solution, Amiego, talk to him, talk to us. Really like to get into contact. And you have our email addresses on the slides too. You'll get. Please, if you want to talk to us about anything, feel free. If it's not about technology, you might not get such a smart answer. But if it's about our technology, we're really happy to engage with you. Just send us email. We're happy to answer them for you. So thank you very much for being here, and see you later at the standing lunch.